Today we have Professor Klein now, who is, whose 80th birthday we are celebrating here. And I'll read out very briefly introduction about his. He was born on March 13th in 1940 in London. And then he studied his bachelor's in University of Bristol, and then he did his PhD, and then he moved to Canada, and where he was there for quite some time until he moved to UPenn and then to Temple. And he received in 1999 Anusur Rahman Prize for Computational Physics. In 2003, Fellow of American Academy of Arts and Sciences, 2003 Fellow of Royal Society of London, and 2008 Peter Debye Award, 2009 elected to United States National Academy of Sciences. So I request Professor Klein to.
Okay, so good afternoon, everyone, and thank you all for showing up to help celebrate my birthday. And I've copied my hero C.N.R. Rao, and I'm proposing to celebrate my birthday many times in the next few months. It seems a good custom, I think. So I'm going to talk about the beginnings of molecular simulation as seen through my eyes, so it will be a very prejudiced presentation. In some sense, I was fortunate that just a month ago, I was in Paris to celebrate the life of Lou Valais. And there's a photograph here of three elderly characters were going in, each to give a lecture in this celebration of Lou Valais. Lou Valais passed away last June, and the French École Normale had this memorial for him. And for those of you that don't know Lou Valais, I'm going to go through some of the slides I used on that occasion. So Lou was the key figure in Europe to bring molecular dynamics simulations alive. He was a physicist through and through. And to me, he was, although you'll hear I was in the lab quite a bit, he was a very mysterious individual, very aloof. There wasn't that much age difference between us, but I did find him aloof. And he reputedly was a fantastic musician, would play the cello and piano, grand piano. I did go to his house once for a party, and he did play the piano for people. And he was the person that hosted me very early in the 70s, where I really learned molecular dynamics as it's practiced. But even more than Lou Valais, the group that he had was immensely generous with their friendships, and this proved to be very, very useful for me. You'll see that Lou gave up on science in the mid-1970s and became interested in social issues, psychiatry, and other things. I'm not going to talk about that, but for those of you interested in reading, his books have not been translated as far as I know, so you better be good in French. So at this symposium, I was given the task of talking about molecular simulation in the 1970s, and this is the slide I made, but to understand the 1970s, you needed to understand the 1960s. And to understand the 1960s, you had to understand the 1950s. And so you'll have my prejudiced view of getting to the 1970s. So the field of computational science began essentially with the delivery of the MANIAC computer to Los Alamos in 1952. And very soon after, a couple of important papers for our field. The most important one is highlighted here, the equation of state by Monte Carlo method. And very unusual for this paper, the women are included in the author list. And it's quite clear when you look up what the women did, this was a genuine inclusion. And then somehow the custom in this field became to not put the women as authors. And in the case of the paper by Fermi, Pastor, and Ulam, retroactively, this has been corrected. And if you Google it, you'll find that Mary Singhu is included nowadays. So I don't know what changed between then and now, with the modern times, but at least the first paper was honest and truthful. So one of the issues is, this method of doing the sampling, the Monte Carlo method, usually an algorithm is invented by an individual, not a group of people. And so there's been speculation over the years. I went through again, and those of us in the field refer to it as the Metropolis algorithm because it's the first author on the paper. But it seems quite clear that in my recent search, of course, these days, as we know from Mr. Trump, there's only fake news. So, but if you search now, you'll find that Metropolis was the owner of the machine, the computer, and therefore his name's there. Now, is Dan around? So is that true? So what I found is that the invention of the algorithm seems pretty clear now that it was Ariana and Marshall Losum together, the pair of them, and not Nick Metropolis. But as we know, Bernie Alder claims to have invented Monte Carlo. And the latest thing is there's actually a footnote in the Metropolis paper where they just say that Bernie has done something similar. But you and I were present when Bernie tried to explain his way of doing Monte Carlo, and it wasn't convincing, so he may have done. Anyway, Bernie did contribute. He did this beautiful papers on molecular dynamics algorithm, and I just highlight those. That was a few years later. So that was the first of molecular dynamics with hard disks and then hard spheres. Very, very important and influential work. So why do I put this picture up? So I was a teenager then, in those years, and in the late 50s, when I was a teenager, the only movies one watched were French movies. And I don't know why, maybe because I was in England, but anyway, did anybody else see these movies? And then things changed, right? Things changed, and as I point out here, it may or may not be significant that molecular dynamics and Monte Carlo were both invented in the US national labs during the Stalin period, the 53 to 64. The simulations were only really done in national labs. Another point, and this is the one I'm going to elaborate on now, is that the Legacy of Valais lab was seriously important to the field in the late 60s and a little bit after that through to the middle 70s. And there was an event in May 1968 when the students took over the streets of Paris, and the people there are very proud of that event. But as I say at the bottom of this slide, Legacy of Valais spent a sabbatical in New York. Leibowitz invited him to Yeshiva University, and I'm going to just put up a slide or two about the 1960s. So to put in context what happened in May 68, you should know that in the United States we had the Cuban Missile Crisis in 62. Kennedy was assassinated in 63. And then there was a series of riots in the inner cities in the US, Philadelphia 64, Watts in Los Angeles 65, Cleveland 1966, Newark and Detroit 1967, Chicago, Baltimore, and DC in April 68. April 68, Martin Luther King assassinated, and a couple of months later, Bobby Kennedy was assassinated. So the 1960s in the US was a little bit different from Europe. So I actually worked at Rutgers in 64 summer in the physics department and 66 in the summer, and decided because of the access to computers that I was going to move to the US from UK. And I sailed with my family to New York, first week in July 1967, and rented a car when I got to New York for all our belongings. And I couldn't actually arrive at Rutgers campus because the streets of New Jersey were full of soldiers in full battle fatigues and also tanks and half-track vehicles. So I think those of you today don't realize what the world was like 50 years ago. So I just tell that story. And the good news, when I went to the United States in 67, the US Embassy gave me a green card. And the bad news was that as soon as I arrived in the US, I had to register for selective service. And I was given an A1 card to go to Vietnam. So you'll see at the bottom, a year later, I was going to Canada along with a lot of Americans my age. Gave my green card back to the US Embassy, honestly and correctly, so I wasn't really a deserter. So as I said, the events in the 60s, and Lou Valais would have been in the middle of this, so he was in New York. So the backdrop of the Cold War and the Vietnam War led to turmoil on the campuses in the US. The most famous ones are Columbia in 1964, 68, and before that at Berkeley, and that led to the prominence of singers and performers like Bob Dylan and Joan Baez, and really very, very influential. And it culminated in August 69 with the Woodstock Festival, which just celebrated its 50th birthday. So that's the backdrop, but it was even more than that. 64, 66, I lived in New York City, and it's hard to describe the transformation of the city as a place of creativity. So the galleries were full of incredible paintings, making movies in the streets, and even more, the movie scene around the world changed dramatically from, whether you like them or not, these were the kinds of movies that were being made. But living in Manhattan, as I did those 2 summers, the off-Broadway theater was much more attractive to me than the movies. I didn't find myself going to movies. I found myself going to plays and even going to bars to listen to jazz musicians. Jazz, to remind you, had gone out of fashion because the Beatles and the Rolling Stones and other performers like that were performing. And so it's hard to put in context the life there with the tension that you had politically and then all the creativity going on. So I won't dwell on this. This is just some highlights. So just go back to me then and be selfish here. So I was a graduate student in 61, but actually did undergraduate research because to get an honors degree, you had to do a thesis, which I did. And my thesis advisor, well, so should tell the story. I decided after I went to university, I'd made a mistake picking chemistry and decided I wanted to do physics, and even more stupid, wanted to do elementary particle physics. So I went to see the Nobel laureate in Bristol, Cecil Powell, and said, can I join your group to do a PhD? So he said, oh, go away and get a first-class degree. Get yourself money, and then you can join my group. So I did that. I got myself a state scholarship and went to register in the physics department to do my PhD and found that my scholarship was to study chemistry and not physics. And so I was not allowed to study physics. So rather than give up the scholarship, I went to see the head of the chemistry department and said, I would like to do theory for my thesis and preferably physics. And Professor Everett looked over his glasses at me and he said, Klein, chemists wear white lab coats. So I thought about that for a while and I said, no, I want to do theory. So he found me an advisor, T.H.K. Barron, who had a PhD in physics but was teaching in the chemistry department, so that worked out okay. And then he went off on sabbatical and gave me some articles to read. And this is the days before internet. So any young people in the room, encourage your thesis advisor to go on sabbatical on another continent because that's how I got my first paper. And the latency between communication was about 6 to 8 weeks. So I made a lot of progress in my first year. On the strength of that paper, I got invited to give papers at conferences, and I've just highlighted on here a few which were massively influential in my career. My first paper I gave at the Low Temperature Physics Conference at London, LT10, 1962. I got 2 offers of postdocs, and I was a first-year graduate student. So that was good. Then the summer of 63, I went to Copenhagen to a conference on lattice dynamics. And in preparing this talk, I was reminded that George Vinyard was there and showed a movie of radiation damage of particles colliding with a crystal, and the phenomenon of channeling had just been discovered. And I certainly, to prepare this talk, I went back and tracked other talks that he gave at that era. But even more important, I went back to find his original paper, and his original paper dates from 1960, where he did molecular dynamics. He didn't call it molecular dynamics, but he did molecular dynamics. And if you read the appendix in his paper, he even used the algorithm that we call the Valais algorithm in many years before Valais. But again, that's another example of the simulation being done in the national lab, in this case, Brookhaven National Lab. So the only thing that came out of my thesis that proved to be useful later was an introductory chapter I wrote on defining the ways elastic constants for materials under stress, how to best to define them. There was nothing original in this paper. It's just that I was trying to worry about the inverse of stress, stressing a material. I was worried about zero-point energy and what does that do to the properties. So you imagine the zero-point energy as blowing things up, so it was kind of a negative stress. And I went and spent a few months in the math library reading all the way back to the works of Cauchy, which I found useful. And I wrote this up, and it was ignored, this paper, for 40 years until the Institute of Physics digitized its archives, and the title is found very easily in Google. If you want to know a material under stress, you find my paper. So now it's a pretty decently cited paper. So again, young people in the room, think of the title of your paper and imagine if you wanted to find it in Google. Most of you have a tendency to write 2 sentences. It doesn't work that way anymore. You need some keywords in it. And this wasn't deliberate in my case, an accident. I told you already I spent summer of '64 in New York because I already had a few papers. And I'd already lined up a postdoc. I got myself a fellowship, which was something I would encourage the students now to write your own proposals. So I was examined for my PhD on my way to Italy, where I had a postdoc position in physics. And the examiner was a guy, thermodynamicist called Max McGlashan. And I've put the quote there. You know much more about your thesis than me, so why don't you prove the Clausius-Clapeyron equation for me? So that took me more than 2 hours, starting from the first law of thermodynamics. So if any of you have an opportunity to examine a student, you might use that line. It nearly crucified me. Anyway. So I was going off to Italy when this paper of Anisur Rahman came out. It caused a big stir. It was another example of something from the national labs. So we've reached 1964, and again, only the national labs are participating in this exercise. There's a story here which I think is relevant for later, that when we were honoring Anis, the 20th birthday of Anis's paper, so in 1984, I gave the after-dinner speech for Anis, and I'll hopefully get to that unless my time runs out. Anis gave a talk at the Curran Institute, and Perkus was in the audience, and Perkus got up at the end of Anis's talk and said, you realize you're doing molecular dynamics in the microcanonical ensemble, to which Anis replied, I am. He had no idea that he was doing statistical mechanics in the microcanonical ensemble. And that actually led to a paper that Lou Valais seems to be the senior author, unless they're just alphabetical, which might be, where they actually, a couple of years later, discussed the fluctuations in the various ensembles, an influential paper. So that's 67, and Lou Valais went and wrote his own molecular dynamics code, and I remember asking Dominique Levesque, his longtime collaborator, whether Dom, as we called him, Dom, did you actually help Lou do that? He said, no, Lou wrote it himself. So it's a massively cited paper, 10,000 citations. And these papers that come before don't get anywhere near that level of citation. So I already mentioned that he was on sabbatical in New York in the middle 60s, a very exciting time. And he had some very, very bright students, and I'll say a little bit about what the group did. When he came back from his sabbatical in New York, he wrote up these papers, what he did with his MD code, and the first couple of papers are single authored. I said this is massively cited. I puzzled over why was this paper so important. It was 3 years after Anisur Rahman's paper. What was special about it? And maybe because it demystified the computation, that you didn't have to be in a national lab to do it anymore. You could just do it as a university professor. Perhaps, I don't know. There's a second paper also well cited on the correlation functions, and there's even a third paper. Another development for the simulation community was a not well cited paper, 200 times only, where isobaric, isothermal Monte Carlo was introduced by M. MacDonald and Conrad Singer. Very important for the works that came later by Bill Jorgensen and others in the biological applications, but I'm puzzled when I found it only has 200 citations. The Valais group was interested in helium and quantum systems. That was the last passion of Lou Valais, very physicsy, and Jean-Pierre Hansen and Daniel Schiff and Dom Levesque published papers in this in the same era. And here's where the overlap with me came, although I didn't know about it at the time. Jean-Pierre published papers on solid neon using variation on Monte Carlo. And at the same time, almost simultaneously, I published papers with my collaborators using quantum lattice dynamics, or self-consistent phonon theory, as we called it, many-body perturbation theory of quantum systems. And as I said, we overlapped almost completely in interest using different methods. Jean-Pierre's thesis was also study of phase transitions, a follow-on from Lou Valais' thing that's co-authored. And this was again Monte Carlo. So at this point, Jean-Pierre himself hadn't used molecular dynamics. This is the final paper that brings us from the Valais group in a sense. I may show a couple more, but so that's the background to the talk I was supposed to give in Paris a month ago. It brings us to 1970. So at that period, the Valais group decided to be interested in molecules, and their definition of molecules at that time was hard ellipses. And that's a true physicist approach, I suppose. So there was a paper then on hard ellipses. But for me, remember I said I headed off for Canada November the 7th, 1968, I remember very vividly, because I didn't make it, actually, because of a snowstorm in upstate New York. And I won't forget that date. But once I arrived in Canada, I realized that, well, Bob Watts and John Barker were in applied mathematics at the University of Waterloo. And I, as a graduate student, corresponded with John Barker. He was in Melbourne, Australia, and reconnected with him. And he told me about his Monte Carlo simulations of water. And again, I think this paper is largely overlooked, but it was the pioneering paper. The paper by Raman and Stillinger came out 2.5 years later, so much, much later. But the thing of overlapping with John was that he survived 2 winters in Canada, and coming from Australia, and he moved to IBM San Jose. He decided he wanted to be a California boy, and immediately invited me to join him, which was great. It gave me an excuse to miss the winter of 1970 from Ottawa. So here's a picture of me at that era with my eldest daughter, Paula. And so I was at IBM, and this particular picture was taken. I was going down to give a seminar at UCLA, and I stopped off to see where Henry Miller used to hide out to write his novels, if you're aware of that. It's the most magnificent place where the Pacific Ocean is covered with cloud, and it's a magical place to stop for a drink. Anyway, so that was me. So when I arrived in the Barker group and to work with John Barker and actually others at IBM, John was trying to do simulations of liquid helium using Feynman path integrals and wasn't succeeding. But I showed these pictures, and for me, path integrals triggered my interest in path integrals because remember I said I came out of the world of worrying about what zero-point energy does to things. And for me, the Feynman lectures that came out in 1972, chapter 3 is on path integrals, and that was very influential for me at the time. So 1970s were what I was asked to talk about, and I can see I've used sort of 2/3 of my time when I was in Paris. But you have to know that the 1960s were different, but the 1970s were very different. So here's 2 pictures of me from the 1970s, and I had a little bit more hair then than now. And here's a picture of me with my wife on the Staten Island ferry going into New York City. 1970 was a chance meeting. I kept collaborating with my friends at Rutgers University, and I would frequently drive from Ottawa to New Jersey. And on one of those visits, a guy called Jim Krumhansel, who was a solid-state physicist from Cornell, became president of the American Physical Society at one point. And he told me that when I drive back to Ottawa, I should stop at Cornell because there was a French guy there doing exactly the same things as me. And so I stopped off to see, there's a picture of Jean-Pierre from that era, and I stopped off to see Jean-Pierre, and we agreed that we would collaborate and do molecular dynamics together. The reason for that is that you needed a serious computer, and there were very few and far between at that time. There was an important meeting of the era on quantum solids that was held in Banff in the late summer of 1971. And we agreed to meet there, and we did meet there. And both of us gave talks at that meeting. And then we arranged for me to go to Paris. And I would say over the next 7 or 8 years, I spent at least 1 month, and one time, 75, 76, spent a whole year at the University of Paris, part of which I used to hang out in the Valais group, or what was left of it at that time. In my own group in Canada, I started doing Monte Carlo calculations. The first publication I have is 1971. But in that era, I was concerned with using the Monte Carlo to test my lattice dynamics calculations. I wasn't using it as a predictive tool. And I got interested in other systems, realistic potentials. I got interested in alkali metals using pseudopotentials. And, but also in the 70s, as I said, the Raman-Stillinger paper came out 2.5 years after John Barker's work. So I'm pretty sure that Barker's paper seeded this idea. There's a beautiful picture of an Nice there that I stole off the APS website. We have a fundraiser to try and endow this prize for the American Physical Society, and this is the photograph used on the website for that. The Valais group then belatedly got into molecules. After that, this is their first paper. I cite that. And then at that same era, there was a big effort by V.A. Baron to model liquid crystals, and some publications came out. I remember that the group members teased him about the difficulty of his calculation. I mean, he worked very hard to do these papers. They're not cited that much, but I think they were pioneering. Is that fair, Dan? Yeah. So another example of the Valais group doing extraordinary things. I tried to do molecular systems in my group in National Research Council. The only machine that was suitable was at the Atomic Energy Lab about 120 miles north of Ottawa, and we could use it at the weekend. In that era, in the 1970s, there was no such thing as security. I could, at 5 o'clock when everybody was leaving work at the reactor, I was going in to work, and I went straight into the machine room, rolled out all the calculations that were going on, and loaded my own. And the machine was mine till Monday morning. And it's hard to imagine that you could do today. You wouldn't even get near the front gate, but that's what we did. So the postdoc that was doing the work, Trevor Gibbons, really got discouraged about how difficult it was to do these computations. And he left the field, and he became an economics professor, statistics. He taught statistics in the economic department and eventually wrote novels. So that's what molecular simulation did to him. This is pretty much Valais' last serious science paper. Mel Kalos spent time at the group and moved their quantum simulation things forward with significant work. And I spent a sabbatical there, 75, 76. So the papers I wrote with Jean-Pierre, the first one we submitted to Physical Review Letters was calculating dynamic structure factor for solid argon, or a model of solid argon. It got rejected from PhysRev Letters. So if you see here, the submission date is 1973. So we sent it to Journal de Physique Letters. It got published, of course. We had to write some French words to satisfy them, but since I was living in Canada and officially bilingual, that wasn't a struggle. But the same code that I'd prepared with Jean-Pierre was used to do one component plasma, but this was accepted in PhysRev Letters, so the argon is obviously not as interesting as the plasma to physicists, so that's probably why. That was the opportunity for me to meet Ian MacDonald, in fact, and he had a long collaboration with Jean-Pierre, published 10 papers with him on molten salts and plasmas. But more importantly, they wrote this book, The Theory of Simple Liquids. And that's a historically important book for people interested in liquids. Said they wrote several papers. And that pretty much, I think, was the end of seeing Lou Valais around the lab. And Ian dragged me up to CCAM, which is on the same campus of University of Paris in the south, at Orsay. And I attended a workshop, Molecular Dynamics of Ionic Systems, where I met Anisul Rahman and collaborated with him and others, and we worked together. And we were interested to put polarization into models of salts and do that by molecular dynamics. I couldn't, because of my job was actually a national lab and civil service, I couldn't stay for the 6 weeks that other people did, and so I went home and told them to publish on their own, but they at least thanked me in the paper for this work. But a legacy of that was that we also wrote up a letter, Gianni Iacucci, myself, and Ian MacDonald, which again we sent to Journal de Physique Letters, and you can see that the CCAM name appears there. And this was before Ian moved to Cambridge. He was at Royal Holloway College in London. I won't bore you with that. So this was 1974, so I have a digression here when I said, what was Dan Frenkel doing in February 1974? Well, there's a photograph of Dan that I stole at a meeting that we were at last year, I think, in Paris. Dan showed this picture. And he wasn't understanding molecular simulation quite yet, right? That came very soon afterwards. But notice the hair. Remember I said the 70s were different. For multiple reasons, but hair seems to be a big correlation. So that work from the workshop, the 74 workshop, didn't appear for a couple of years. I guess the people dispersed to their home institutions, but Anis did get that paper published, but a couple of years later. My collaborations with the Valais group continued a little bit, but again on the same themes, moving to molecules, but actually my collaboration shifted more to work with Ian MacDonald, and over the 20-year period from 74 to 94, somewhere around there anyway, we published about 50 papers together on many aspects of molecular crystals mostly, but also liquids. I have one paper with Bernie Alder, which again from that era of sabbatical, which was a small paper about light scattering. I said I worked on liquid metals. There's a story there that's best told over a drink when my publishing papers on liquid metals attracted the attentions of the Soviets that were trying to build breeder reactors. And I was interviewed by the Canadian Secret Service as to why the Soviets would be corresponding with me. And the only offer I could suggest, I was the only one on the planet that could model liquid metals. So that may be a reason. So the summer of '55, Jean-Pierre and Ian spent 3 months with me in Ottawa, where they finished their book. And that was a happy occasion for all of us to cement our friendships. And the book did appear, fantastic book, gone through several editions now. Look at the number of citations, 14,000. So that's that period of the Valais group more or less disintegrating and ceding its place as the important disseminator of molecular dynamics to the university communities. They ceded it to CCAM. So there's a very poor picture of me with my kids in Paris. And again, the hair is the dominant feature, I think. So there were two or three straggling papers that I did with these guys that some historical importance. But I skipped over people that went through the lab that I didn't overlap with because they both came after I'd left, gone back to my real job. Glenn Torrey and John Valot were frequent visitors, and they created umbrella sampling, which many of you would know. And David Sepperly was a postdoc there, 76 to 77, which again was after my association, and published his beautiful papers. And then went off to do, for those of us who do electronic structure, did this work with Alder on the electron gas soon after that. Again, note the hair. It was a feature of the time. So I've got a kind of summary here that I just go through. So from the mid-60s to the mid-70s, I would say that the Valais group was the most important, and sort of adiabatically at the same time, CCAM took over. And it was an important, very important for me. And anybody who was anybody in the field passed through the lab at that time. So I'll go pretty quickly through a few other things to get us through the beginnings of the 1980s. But before doing so, I wrote to Michael Levitt last year because there was quite a bit of uncertainty in my mind. How did biological MD start? And I've just copied verbatim Michael's reply to me, which was an email. And he said that 1968, he was doing energy minimization of proteins when he was with Lifson. But in 1975, when Ariel Warshall visited him in Cambridge, Ariel had an MD code that could do molecules, conformational changes in molecules. But then he says in the middle there, I first heard of protein mechanics from Martin Karplus in Paris 3 weeks before the June CCAM meeting, and where Martin showed him Andy McCammon's work. And then he says he scampered back to Cambridge and wrote his own MD code. And he says there earlier that Ariel had told him to read Goldstein's Mechanics, and he said it was far too difficult. So he says here, but that both he and Andy McCammon had working MD codes in that CCAM workshop of '76. So I think it's this letter, at least in his mind, justifies why the three of them shared the Nobel Prize, because they all did it pretty much at the same time. But from the point of view of those of us that watch the methodological development of modern MD codes, this was an incredibly important paper here, the 16,000 citations. This was Jean-Paul Ricard's thesis, really, about the way to handle the stiff CH vibrational frequencies. Really beautiful and important, influential paper. But that was a CCAM work. It had nothing to do with the Valais group. So I'm going to indulge you with a few more minutes, but let's talk about the 1980s. I've already explained to you what was going on in the 70s. From the point of view of chemists and biologists, not much, but at least the foundations of the field were laid. And the period I want to talk about now is the Reagan years. And for me, the important things were phase transformations, which became accessible, path integrals and quantum solutes, and very importantly, ab initio molecular dynamics. So I'll go through this relatively quickly. For me, the key and most important paper was written by Hans Andersen. And Hans was interested in studying glasses, and when you cool most systems, they contract. And so your simulation box didn't adapt to, and so you were putting your system under stress. So Hans was the guy that wrote down the extended Lagrangian formulation of molecular dynamics, coupling the box volume as a dynamical variable. It's a significantly cited paper, as it should be, but was extremely influential. Soon after that, Micheli and Anis published their paper, and that's a picture of Micheli from that era. The hair has changed, Micheli, right? So 80s were not the same as the 70s. Yes, this has been used again in, as those of you, the cartoon version of that is commonly used for getting from one basin to another basin, right? Anyway, this was an influential paper. And the follow-up paper the next year was equally important, if not more important, acknowledging the Lagrangian formulation, but for arbitrary stress. So the simulation box could change not only its shape, but it could shear and so on. So that was the era when, I spent a few months in Kyoto with Joshin Yamamoto, who was interested in rotational tunneling, which I was interested in at the time, methane. I had Sprick in my group and people like that. And so that was an influential period for me. But most importantly, I got to meet Shuichi Noze, who came back to be a postdoc in my group. And very, very important happening was back on this previous slide here, where summer of 1980 at the Gordon Conference on Liquids, Anis came running up to me waving a preprint of this particular paper here, saying, "Mike, you should do this for molecules." So obviously Anis had decided it was too difficult for him to do as for molecules, but he thought I should do it. It took 2 years. And our first paper was a PhysRev letter, and that's from the era, a couple of years after that, and we called it Anderson Paranella Raman, which I think should be the correct title, just because of the history here. And Shuichi applied this to molecular systems with great effect. And it was important that we had that work because it led to the collaboration with Bill Jorgensen on modeling water, where he was having some difficulty with changing density. And so cross-checking his code, which was Monte Carlo, against ours, molecular dynamics, led to this important paper. But Shuichi wrote up a nuts and bolts paper on how you do these things in molecular physics, pretty well-cited paper on how you do these things. But then he came into my office one day and said he figured out how to do canonical molecular dynamics. And he tried to explain to me what he was doing, and I said, you better write this paper up with just your name, because I haven't a clue what you're talking about. And that came to be this pair of papers that he wrote were massively cited, this one, and then there was the follow-up paper, which has even more citations. So all that work I showed you was done in less than a year by Shuichi Noze. And then one day he came into my office and said, Kubo is on the phone and he's offered me a job. Should I take it? So I said, do you want to go back to Japan? And so he said, yes. I said, go and tell Kubo that you're coming. So obviously people outside the field had noticed what he was doing. Unfortunately, he died, very young man, of cancer. sad loss for the community. But here I can't skip without mentioning Dan's work from exactly the same era where phase transitions were done. In Dan's case, he was interested in models of liquid crystals and was able to work out the phase diagrams. I think very important papers for us. This one is cited more. Don't know why, Dan. For me, the first one was more interesting, but is this because it might be clay or something? Or?
It is on the cover of one of the James books.
Okay, explanation. All right. But anyway, for me, this one showing the phase diagram was anyway. And then this important paper by Dan on free energies, which are obviously important. I could not find a photo of our friend Tony Ladd. He is invisible on the internet. I don't know how he managed it, but he just doesn't exist. And then Dan did yet another paper and even more about this. So this was a very active period of liquid crystal work, which was very influential. I'm getting close to the end, but I can't resist without talking about temperature is imaginary time. Gives me a chance to talk about something which at the time was very interesting to my group and also Michele's group. And but we can't ignore Bruce Byrne here. As much as we may love him and hate him, he did influential work. And there's somebody else there that has hair, but from the wrong era. You're not invisible on the internet. Finding Bruce with hair is difficult. Anyway, these are very important to help teach us how to do this work. And in fact, Mikhail Sprick and I came down to visit you guys at Columbia. I don't know if you remember that, do you? Yeah. Very important. But then we each got involved with quantum solutes. Michele did the F center in alkali halide, and I picked up a problem completely independently. I gave a lecture at the University of British Columbia, and somebody there from the meson factory said to me, can you model muonium? It's a quantum particle. So I said, sure. And then when we got back, we worked on that. And there was a controversy as whether this light hydrogen, the muonium, the mu minus, whether it would scavenge and become charge neutral, but did it go through the interstices or did it make a bubble? Was the controversy at the time. We concluded it made a bubble, but I don't know, I didn't follow after that. David Chandler got us interested in electron localization. It was a collaboration. Then I got interested in metal ammonia solutions and metal insulator transition, but I'm not going to go into any detail. But there is a seminal event that happened. So I organized a meeting for the Canadian Institute of Chemistry in Montreal, 1983, and invited a lot of the top people in the field. They came, and we decided we should celebrate ANICE with the 20 years of molecular dynamics, and quickly got it organized. David Chandler was influential in approaching Argonne National Lab and funding. Priya was at the time the head of physics, I think. Anyway, they got the money to organize this big meeting. And I'm going to show a couple of photographs because I think they're historically important. Well, that's the group of us that organized the meeting. That's not so important. But there is this photograph, which is pretty much a who's who of the field at the time. I've tried to blow it up here. For those of you that don't know, this is Peter Roski, this is Bob Watts, this is Bill Steele, this is Jadi Rahman, this is somebody that actually has hair, right? There's Sidney Yip, there's Bill Hoover. I mean, I could go through. There are a couple of, this is Charles Bennett, there's Bruce, David Chandler, Hans Anderson, and we've got somebody here with hair. And if we look hard, we might find the other character. And there's Johnny Yakuchi up there. But there's John Valot. But there are actually a couple of Nobel laureates. There's John Popel, next to Jean-Paul Ricard. And somewhere we've got John Polanyi on there. I'm not seeing him at the moment. There's Mr. Angel, glass transition, Sid Nagel. Anyway, anybody showed up to honor a niece, which shows you really how the community felt about him. Now, why did we do that? Because 2 years before at the Gordon conference that he and I were both at, we were walking on the beach in Santa Barbara, and he told me he had cancer. Well, he didn't say cancer at the time. He said he had tremendous pains in his stomach. So I said, well, why don't you see a doctor? He said, your wife's a doctor. So anyway, but it turned out that he was ill, and seriously ill. And we organized this. But it's a testament to his status in the field. It's just incredible. There's another photograph that from the era of a different set of people. This is a collaborator from Argonne, Singui. There's a guy called Mike Rowe here. And this is a better picture of Michele, I think, right? That one from that era. And there are other influential people. So at the banquet, I actually wrote and read a poem, which I'm not going to read now, but Anise, I had my own PC at home. I'd had for a couple of years. Since I was in Canada, we imported machines from China, which you couldn't in the US. And it was just a rip-off of the IBM PC, right? And so for about a fifth of the price. So I had my own one, and I wrote this. Actually, the reason I bought it, I had to do an index for a book that I'd edited. And I wrote this poem. But when I got back home, the machine had crashed, and I lost it. And so I wrote to Anise, or actually I phoned him, and said, did you keep a copy of my poem? And I'll get to his reply in a second, but notice this photograph of me, which was taken in his apartment at that time. I've got in my top pocket an IBM punch card. And what we would do in those days very often is scribble a note on the punch card, address it on the other side, put a postage stamp in it, and post it. So that was our internet back then. And I can prove it because here I'm going to show you. So I worked for the government, so my mail was opened. And Anise had the habit of just saying, Mike Klein, Sussex Drive. And that tells you the Secret Service were looking at the mail. But anyway, it came in. It's the date stamp. It's November the 22nd, the time it arrived. And it appears on my desk in a folder. And there he writes to me, November the 14th. So there was considerable latency, right? I really did find the original poem he's saying safely on my desk. I'm sending a copy. I'm at a loss for words, so I'll just say, anybody read Urdu? That's what I'm told it says. So that, I mean, I was really well connected with Anise, and we phoned each other frequently, and right up till when he passed away. 85, I wrote a review, don't have time. In that review, though, I did summarize the ways of doing simulations and who contributed. So I think this is an interesting diagram. And actually, Yashonath, your name appears there because you did do the generalization of the variable box shape to study molecular glasses, in fact. And as I put there, Nose did the generalization to molecules, at least rigid molecules. So this is pretty much my last slide. There was Verena School organized by Chicotti and Bill Hoover. And Michele, in the published volume, Michele has a chapter on crystal structure transformations. But actually, he didn't talk about that. He said everybody's allowed two loves, if I remember correctly. He said, I'm going to talk about my second love. That's not. Okay, oh, so not only two. Well, so what I put there is you spoke about your new love, right? I didn't say second love. Anyway, he did. And So I have a photograph from that conference. I don't know if other people have seen it. I call them the new generation. And again, there's a shot of down there with hair and Jean-Paul Ricard. And also Paul Madden, notice. Paul was at the meeting, and Mike Allen is there, and Richard Lassar, and Mauro Ferrario, and so on. And literally days after that conference, so let me just go back. It is ended August the 2nd, and you'll notice that this was submitted August the 5th. Carl Perinello was born. And I like this picture of Michele. He's standing by a poster advertising a politician that wanted to be elected called Perinello. Anyway, the incredibly important paper to us. Actually, not much happened in the 1980s. Not much happened. The computers weren't able to do anything useful, although people tried. And I felt I should include Stefano Baroni because his contributions were important, and they're important to the present time through quantum espresso, right? Well, you acknowledge him in the paper, right? Stefano Baroni for precious suggestions. Yeah, so I'm almost at the end. Apparently we're late for the drinking, so. But no, I've got to finish, right? Because unless you want to read the slides. So who was Anis Rahman? I gave a talk, I think in Kolkata, actually, 2007, something like that, on Anis. And I wrote to Joe Hauptman, and Joe was jointly supervised by Anis and Woods Haley at University of Minnesota in physics. And I've quoted there. And as he said, he was a very special person. He said, I disputed something in a lecture and I went to see him. And he said, well, let's suppose what you say is right. And then we went on to work it out. So I think that he captured for me the humility of Anis, treated everybody as an equal. And then Nobel Prize 2013, Michael Levitt called me up and said, do you have a picture of Anis? Because they don't exist on the internet. And this picture I cropped out and was able to answer. And he used in his lecture this picture of Anis. So I'm last but one slide. So what about the legacy of Valais? So I said for a brief period from the mid-60s to early 70s, the open attitude of his lab, which I guess was influenced by his time in the US and working with people in the US. Anybody who was anybody passed through his lab. And it was a fantastic place to visit. You were made very, very welcome. And then it disappeared, and the reason it disappeared wasn't only that he gave up his interest in fundamental science, in fact, even published saying we should not do research, which I find hard to accept. But then CCAM took over, and computers proliferated, so its importance diminished, and CCAM picked up the mantle for chemistry and biology. And I'm going to end with this quote, which was Jackie Kennedy's after Jack was killed. And she quoted this thing here, do not let it be forgot, there once was a spot for one brief shining moment that was known as Camelot. And she said, there will be great presents again, but there'll never be another Camelot. So I think in this context, it's not so much about Valais, it was the atmosphere in the lab. So I'm going to end there. Thank you.
We have time for only a few questions. Okay.
I think you should call for comments where I've misrepresented.
Okay, so we now conclude this session.